All right, students. So this was a quiz we used when we were online with the Quadratics unit. So it's posted here just for you to get some extra help. Good problems just about identifying what pieces of the graph are easily identifiable from different versions of the equations. So when I look at this first one here, it says y-intercept, and by now your brain should be thinking x equals 0. I really want that to be something that happens automatically, that whenever you read or hear the words y-intercept, your brain makes the next step to think, oh, y-intercept? That means x equals 0. And if you make x equals 0, you'll see that disappears and that disappears, leaving you with negative 24. And so the y-intercept is 0 comma negative 24. Factored form is a little bit harder to just see right off the bat. That's what we've usually used an area model to complete. X squared minus 24. X times x makes x squared. 24 is a bit tough because it could be 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. So there's lots of different ways that could be 24. The one that turns out to work here is because of the negative 5x. That makes me think I'm subtracting my factors. And 3 minus 8 is the only way that I can get a negative 5 by subtracting my factors. So I know it's got to be a 3 and an 8, leaving me with the 3x and an 8x. And I need that 8 to be negative so that my middle term, my negative 5x, is negative. So I know I need a negative 8 and a positive 3, leaving me with this correct factored form right here. By the way, this one, oops, I didn't mean to clear the screen. This other one here would be x squared minus 2x minus 24. Not quite right. This one would be x squared plus 2x minus 24. And this one would be x squared plus 5x minus 24. So you can see that they're all close, but none of the other ones are correct. Okay, moving along. What are the x-intercepts? Well, if you think of x-intercepts, just like earlier, that should make you think that the y value is 0. And so if you go back up to your previous answer on factored form, you want to make the y value 0, and there's two ways to do that. To make this part say 8 minus 8, because that equals 0, and to make the second set of parentheses say negative 3 plus 3. Those are the only two ways that you can make it equal 0. 8 minus 8 or negative 3 plus 3. So we have these answers here, 8 comma 0 and negative 3 comma 0. You're trying to tell me what number x can be that will make the parentheses and therefore the whole equation equal 0. Okay. Question 4, they gave it to us in factored form. So I want to think about what number makes this 0, negative 4 plus 4. And what number makes this 0, 3 minus 3, leaving me with those x-intercepts. Standard form you get by distributing it out, or you can think of it as FOIL. Some people like the FOIL. So FOIL leaves me with this one, x squared plus x minus 12. What's the y-intercept? Well, based on the work I just did and what I talked about on number 1, 0 comma negative 12. Last one, bit of a challenge. Factoring something where the a value is not equal to 1. We can use our area model of 3x squared and negative 20, knowing that 3x squared is 3x times x, and trying to get a 7x in the middle. Well, 20 has lots of different ways. It could be 1 times 20, or 2 times 10, or 4 times 5. 1 and 20, I don't think I could make those into a 7 because they're too far apart. 2 and 10, it's possible. No, it's not possible, but it's hard to see exactly why. What I'm doing is multiplying by 3. 3 times 2 is 6, and that's only 4 apart from 10. I can't get 7 from it. But 4 and 5 does work. If I put a 4 here and a 5 here, that's 12x, 3 times 4, and 5x. And if I subtract 5 from 12, I get the 7, which is what was required. So I've got 3x minus 5 and x plus 4, like that. You can always double check your work by going like FOIL. And by the way, this is the sort of question I've seen this sort of thing several times on like the SAT. And you may on the SAT not remember this area model. And that's okay. If you don't remember the area model, that's okay. You can always take each of your answers and distribute them out because you better remember the distributive property. And if you distribute each of these answers out, there's only one of them that actually results in the original quadratic. So it's just something to keep in mind when you're doing a multiple choice test. You don't always need to go from the question to the answer. You can go backwards from the required one from one of the provided answers and then figure out which one matches with the question. So that's always a good strategy to keep in mind. Please comment if anything was confusing or if you want more examples of a certain type of problem. Happy to do that. Thank you for watching.